Hello, this is Mrs. Sargent, and this is lesson 1.4, Significant Figures. So what are significant figures? Significant figures are all of the digits in a measurement that are known plus a last estimated digit. So with the rulers of measurement activity, we looked at significant figures because you estimated one place past that smallest graduation or marking that you were given on the ruler. Here is another example of significant figures. We have this blue ink pen, and it is lined up on a ruler. And this little box is zooming in to look at the tip of the pen to see what the length of the pen is. And we can see our last known graduation is right here at 4.7. But the tip of the pen is in between 4.7 and 4.8. So we need to estimate that last digit. And so if we were to look here, the tip is just past there. It looks like it is less than halfway between 4.7 and 4.8. So you could estimate it to be 4.72 or 4.73 centimeters. Either one of those would be perfectly acceptable. What one person estimates the length of it to be could be very different from what another person estimates the length of the pen to be. So there's some rules to determine the number of significant figures. The first rule says that every non-zero digit, numbers 1 through 9, is significant and counted. So in our example over here, the number 3,539 centimeters, we have no zeros, so all 4 of these digits are significant. So we have 4 sig figs, and sig figs is just a shortened version of significant figures. You may also hear sig digs. I typically use sig figs, but you might hear that in other classes. Sig digs. The second rule says zeros between non-zero digits are significant, so you can think of these zeros being bookended by non-zero digits or sandwiched by non-zero digits. So the number 7,003 meters, these two zeros are significant because they are sandwiched in between two non-zero digits. So we have 4 significant figures in that number as well. The third rule states that leftmost zeros in front of non-zeros are not significant. So 0.00021 kilograms, these zeros are not significant. So just the 2 and the 1 are, giving us 2 sig figs. The fourth rule states that zeros at the end of a measurement and lie to the left of an understood decimal are not significant. So what we mean by an understood decimal is 12,000 is a whole number, but there is no decimal given to us. We understand or assume that the decimal is at the end of the number, but since it is not given to us, these zeros are not significant. So we have 2 sig figs in that number as well. And the fifth rule states that zeros at the end of a number and right of a decimal point are always significant. So 9.20 milliliters. Because of this decimal right here, all 3 of these digits are significant. So we have 3 significant figures in that number. So these rules will help you determine how many significant figures there are. I have a shortcut to help you with it. If you take a look at North America or the United States on a map, the Pacific Ocean is typically on the left side or the west side. And the Atlantic Ocean is on the right, or on the east side of the United States. So Pacific Atlantic. I want you to write in, is the decimal present? So Pacific starts with a P, present starts with a P, so they go on the same side. So if I give you the number 0.005060, the decimal is present, so we are going to start on the Pacific side of the number, or the left side of the number. We are going to go over to the first non-zero digit, which is the 5, and go all the way to the right. So we have 4 significant figures in that number. On the Atlantic side, I want you to write is the decimal absent. So the Atlantic side goes with absent, A and A. So if I give you the number 12,600, the decimal is absent, so we're going to go over to we're going to start on the Atlantic side, the right side, go to the first non-zero number, and go all the way to the left. So we have 3 sig figs in this number. So that is called the Atlantic Pacific shortcut. So the Atlantic Pacific just tells you how to summarize those first 5 rules that we had in order to determine the number of sig figs. When we're doing calculations, we have specific rules for that. So to round a number, we first need to determine the number of significant figures in the final answer, and then we're counting from the left of the number to the right, no matter if the decimal is present or not. So here in our examples, we want to round each of them to 3 sig figs. So that was predetermined for us how many sig figs we needed. The second rule says if a digit immediately to the right of the last sig fig is less than 5, the last sig fig stays the same and all of the following digits are dropped. The third rule states that if the digit immediately to the right of the last sig fig is greater than or equal to 5, the last sig fig is increased by 1. So if you look at the numbers, we did our calculation. These are the numbers that our calculator gave us. So the first one is 0.001232. So if we look at this to count the number of sig figs that we currently have, decimal is present, start on the Pacific or the left side. We have 1, 2, 3, 4 sig figs. But we only want 3. So we're going to start on the left side at the first non-zero, and we have 1, 2, 3. The number immediately to the right is less than 5, so the last one stays the same and the rest are dropped. So our final answer is 0.00123. In the number 20.3711, We're going to start on the left and count over 3. So there are our first 3 sig figs. Look to the number immediately to the right. It is greater than 5. So our final answer, we have to round this up to 20.4 for 3 sig figs. And then our last number, 345,560, we are going to start on the left, count over 3 digits from the first non-zero, so 1, 2, 3. Immediately to the right is a 5, so we got to round up. So we are going to round this up to 346,000. We can't just round this to 346, and that's typically what people want to do. These zeros are not significant, so that gives us 3 sig figs. They're just placeholders. But think about it, if you were doing a fundraiser and you raised $345,560 and the donor that you were working with said, oh, I'll just round it to 3 sig figs, you want them to round it to 346,000. You don't want them to round it to $346. So those are the rounding rules. And then we have specific rules for addition and subtraction. So with addition and subtraction, the answer is rounded to the same number of decimal places as the measurement with the least number of decimal places. So I like to go through and count my decimal places to start with to figure out how many I need in my final answer. Well, I have 2 decimal places here, I have 1 here, and I have 2 here. So my final answer needs to have 1 decimal place. So when we add these together, we get 369.76. And these are all meters, so our unit is meters. Well, this has 2 decimal places, so we only want 1. We look immediately to the right. It is greater than 5, so we need to round this up to 369.8 meters. In our next example, we have 74.626, that is 3 decimal places, and 28.34 is 2 decimal places. So our final answer is going to want to have 2 decimal places. So if we take 74.626 minus 28.34, we get 46.286 grams, but that's 3 sig figs, or 3 decimal places. We only want 2, so 1, 2, greater than 5, so we're going to round this up to 46.29 grams. And whenever you're doing a calculation, it's always helpful if you box or circle your final answers. Especially as the year progresses, we will have more complex calculations that can tend to get messy. And if you circle or box your final answer, that will help me find where you ended in that problem. For multiplication and division, the answer is rounded to the same number of total significant figures as the measurement with the least number of total significant figures. So 7.55 meters times 0.34 meters. When we put that in the calculator, you get 2.567 meters. Meters times meters is meters squared. So let's look at the number of significant figures. All of these are non-zeros, so all three of those are significant. 0.34, the decimal is present. Start at the first non-zero, go over to the right. So we have 2. So our final answer needs to be rounded to 2 sig figs. So starting on the left, 1, 2. This is greater than 5. So we are going to round this up to 2.6 meters squared. And then in our last example, it says 2.453 seconds divided by 8.42 seconds. We have 1, 2, 3, 4 sig figs in our first number, and 1, 2, 3 sig figs in our second number. So our final answer is going to need to have 3 sig figs. So 2.453 divided by 8.42 is going to give us 0.2913, and it keeps going. But we only need 3 sig figs, so 1, 2, 3. This is less than 5, so we're going to round this to 0.291. And since we're dividing, the seconds actually cancel out. It's just a ratio, so we don't need any units on that number. Otherwise, your numbers need to be labeled with units because I don't know what the number means if I don't know what the units are. So that's all for the significant figures. You need to take a look at the practice in your packet that has to do with significant figures at the bottom, on page 11. Work through those and let me know if you have any questions. Thanks for stopping by. Have a great day.